Hey everybody, this is Mr. Munson, and we are in the second part of Unit 2. We're working with special parallelogram properties that apply to rectangles, rhombus, and squares. And so, no new vocabulary today. Those were all covered in 8.1 that we need so far. This is part 1, so we're going to have a part 2 video, and let's go ahead and get started. By the way, that is Bora Bora, which is this picture is a very famous shot of Bora Bora, and I know personally I like to put this on pause and look at that at this time of year and just imagine myself being there. You're welcome to do that as well. All right, let's take a look at a couple of things. First of all, you need to have your properties chart correctly filled out. That's one of the first pages that you had in your packet. If you don't have that shaded in or checked off, whatever, you need to go back and look at 8.1 and get that finalized. Let's take a look at this problem here. We're going to assume that GRAM is a rectangle. So let's first of all make sure we understand all the properties of a rectangle. Okay, so in the category of sides, opposite sides are congruent, opposite sides are parallel. In the category of angles, all the angles are the same. They're right angles. And in the category of diagonals, the diagonals are congruent. So in this understanding, GA in my diagram, GA, if it was 10, then RM is 10. Okay? As well as the diagonals bisect each other. Okay? So we need to remember that. So if, since they bisect each other, we know that these two pieces are congruent to each other, and these two are congruent to each other. Now, since it's a rectangle, and we know the entire diagonals are the same length, then we find out that, in fact, the little pieces are all congruent to each other. Okay, let's look at some questions about this. Okay, so there's the first question. Take a look at GA is 15.3, and now I'm asking you what RS is. Go ahead and put me on pause, and then I want you to try to think that through. If you get stuck and you have no idea, then come back and take a look at my work. All right, well, since GA is 15.3, that's given, right? Then RM is 15.3 because it's a rectangle. Rectangles, diagonals are the same, okay? Since RM is 15.3, we're looking for RS. The diagonals bisect each other. That means RS is half of the entire thing. Okay, so I just took 15.3 and divided by 2, and I got 17.65. Okay, let's take a look at this problem. Same information, so you might recopy the drawing, whatever you need to do. So I'm given that angle 1 is 5t, angle 3 is 8t minus 1, and now I'm asking, what's t? That means I have to write an equation, okay? So see if you can think through an idea of what kind of equation you could write that's true about those angles or whatever, and then come back and check and see if it pans out to be the same kind of solution. Now, there's different ways of doing this problem, so if I do it differently than you, you would want to know, is my way correct? If you do it differently than me, then come in next class with your question, and let's talk about it. Okay, the first thing I would do is write the information in there. So I know this is 5t, and this is 8t minus 1. Now, the next thing I want you to start realizing from experience, now you might not see this is why you're in geometry, is for me to show you this. This triangle right here is part of those angles. And since it's a rectangle, I know that right there is a right angle. So now, to write an equation, I could say 5t plus 8t minus 1 plus 90 equals 300 or 180. That's the triangle sum theorem. I'm going to go a little bit quicker. I know that in a triangle, the two acute angles, that's 5t in this case, and then 8t minus 1, have to equal 90 degrees. I'm just basically subtracting away from 180 the 90-degree angle that's given. So now it's just a matter of solving that equation. Okay, and so that's an example. Now, what I need you to understand is this. There is tons of problems out there that we could be dealing with these characteristics of rectangles. And so the only way you're going to get used to them is thinking through on your own and thinking through, you know, what is the relationships? What are the things I already know? Where's this right triangle and all those kind of things? And I can't spend a video showing you every single case, right? So you have to be able to think through these things on your own. That's part of being in geometry, part of growing up, part of being in high school. So let's move on. Okay, so let's take a look at a rhombus. Okay, so here's a rhombus, and we'll just call it GRIP for grip. And let's look at the characteristics. All right, so we have under the size category, all the sides are congruent. Under the angles category, opposite angles are congruent. That's because it's a parallelogram. Consecutive interior angles are supplementary. Again, a parallelogram trait. Nothing new there. Diagonals, now these are new because of the sides being congruent. All of them being congruent, the diagonals create some special characteristics under a rhombus, and that is they're angle bisectors and they're perpendicular. Okay, so if I was to draw in those diagonals, what we find is, first of all, they're perpendicular. Okay, so they form right angles. Immediately, I start thinking unit 7. Not necessarily have to be that, but they immediately start creating right triangles. I'm thinking unit 7, Pythagorean theorem, special triangles, Pythagorean or the trig stuff. And then the other thing is that the diagonals are perpendicular and they bisect their angles. So whatever this whole angle is here, half of it is here and half of it is there. Okay, and that's true for all the other angles. The diagonals bisect each other. Now, one more thing. The diagonals bisect each other, so we know that these are cut by the other diagonal, and these are cut by the other diagonal. Now, unlike a rectangle, those pieces end up being different. That's why I have them single stretch. Oops, I need to do this as a 3 stretch because 3 mark because I already have single marks on the sides. So those pieces are different in length. The entire diagonals in a rhombus are different lengths. So when you bisect them, they end up being smaller pieces. They're not all congruent to each other like they are on a rectangle. If you're not sure what I'm talking about, go back and look at that part of the video. All right, so let's take a look at this rhombus, okay? So this is a rhombus. Sorry, I didn't say this. So this is a rhombus. And so we're given that measure of angle 1, let's get that in there, measure of angle 1 is equal to 40 degrees. The measure of angle 3 is in question, okay? So we're looking to see what that is. So we have to think through our characteristics and ask ourselves, how do we go about finding this? Well, the first thing I would do is always write in my information. So I'm going to put 40 here and 3. This angle here is where the question mark is. Okay, so what do we know? Well, to help us, we know that the diagonals meet at a right angle, so those are all 90 degrees. So now I'm dealing with a right triangle, right? So there's that triangle. Angle 3 is at the top. That's what I'm looking for. There's a 40 down there. That's a simple problem now. I just need to look at 40 plus the measure of angle 3 is equal to 90 degrees, right? The two smaller angles have to equal 90 degrees. So the measure of 3 is simply equal to 50 degrees. So I have to use those properties to come up with equations. So again, we're going to have a whole bunch of different scenarios for rhombus. And so these kind of figures, so you have to know the characteristics. The more you write them down, the better. If you did not take notes when I was just writing down these characteristics, you're like, hey, those are in my chart. Just understand you're not getting an opportunity to, again, write down and solidify in your brain what the characteristics are. Okay, there you have it. There's your try-it problems. I'm going to scroll through the try-it problems for those people that might have a little bit smaller display. So if you want to put this on pause, you have it big enough, you can read it. Fantastic. Otherwise, I'm going to take the last few seconds to scroll through it. All right, here goes the scrolling. Stop it whenever you need to and put it on pause so you can see it. Have a fantastic day, everybody.